We're going to complete the square when we have a leading coefficient. So instead of just n squared, we've got 6n squared. How do we deal with the 6? Well, first we're going to do what we usually do when we're completing the square, and that is you want to get all the n's and the n squareds together on one side. So I'm going to move the 9 n's on the right side to the left, and you just get 6n squared minus 9n equals 27. Alright, and now we have to deal with this leading coefficient, and unfortunately the way that we do is by dividing every term by that leading coefficient. So we're just going to divide everything by 6, and unfortunately we're going to get some fractions. So 6 over 6 is 1, so the n squared is now n squared. That's good, that's what we want. 9 over 6 can be reduced, right? I can divide both 9 and 6 by 3, so we can do that. And we will get a 3 over 2n. And then over here, I'm going to leave a little space for when I get to completing the square. 27 over 6. You can also divide both of those by 3, and you'll get a 9 over 2. Okay. Now we got to complete the square. So remember, this part involves dividing that number by 2 and then squaring it. So I'll write over here off to the side like 3 over 2 divided by 2. Remember, if you're dividing by 2, it's just like multiplying the denominator by 2. So that's going to be 3 over 4. Okay? And then we're going to square that. So 3 over 4 squared. And that just means you square the 3, so you get a 9. Square the 4, you get a 16. So we got 9 over 16 that we're going to add to the left side. We got to add the same thing to the right side. 9 over 16. Okay. So now this is a perfect square. And remember, when you're factoring a perfect square, you just take the variable and then take this number here, this middle number, and divide it by 2, which we've already done. That's going to be minus 3 over 4, and the whole thing is squared. Over here, we've got our work cut out for us a little bit. Look at that. We've got a 9 over 2 plus a 9 over 16. We got to get a common denominator. 2 goes into 16 8 times, right? So I can multiply 9 over 2 by 8 over 8. And what am I going to get? I'm going to get a 72 over 16. And now I can just add these together. I've got common denominators, so I'm going to get 81 over 16. And I actually like that because 81 and 16 are both perfect squares. So now I come over here, I'm going to write it in here, 81 over 16. We're going to take the square root of both sides. Okay? And when we do, now we just got n minus 3 over 4 on the left equals plus or minus square root of 81 is 9. Square root of 16 is 4. Ooh, I really like that because these are common denominators, right? So now we just need to finish the problem. Add 3/4 to both sides. And we get 3 over 4 plus or minus 9 over 4. Okay, so let's just do these two operations. What about when it's plus? Well, 3 over 4 plus 9 over 4 is 12 over 4, right? And 12 over 4 is just 3. So there's one of our answers right there. It's going to be 3. What about when we subtract them? I'm going to have a hard time blocking that out. 3 over 4 minus 9 over 4. Well, now, what's 3 minus 9? That is a negative 6. So this would be a negative 6 over 4. But that reduces to negative 3 over 2. So there's the answers for problem 24 right here. Okay, here's another one. Problem 28. Again, to complete the square, we're going to begin by just go ahead and moving the 1 over to the other side. So we'll get 3t squared plus 24t equals a minus 1. And now we have that leading coefficient we still need to deal with at 3. And so we're going to divide everything by 3. Divide this by 3, divide this by 3, and divide that by 3. And what we end up with now is t squared plus 8t. I'm going to leave a little space. Equals negative 1/3. Okay. So now we got to complete the square, right? I'm going to add something here and add something here. Do the same thing we did for the last problem. Divide that by 2. Square it. 8 divided by 2 is 4. 4 squared is 16. This is now a perfect square on this side. So remember, when you're factoring, I'm just going to bring the t down, take that number, divide it by 2. Plus 4 squared. Okay. Over here, unfortunately, we got some work cut out for us. I got negative 1 over 3 plus 16. I need a common denominator. That's going to be 48. I want to change this to 48 over 3. I'm going to multiply 16 by 3 over 3, and I get 40 over 3. So this is going to turn into 47 over 3. All right, so that's what I got on the right side here, unfortunately, because those are not perfect squares. So when we take the square root of both sides, messy square root signs there, sorry about that, we're going to get t plus 4 is equal to square root plus or minus square root 47 over 3. Okay, so like I've told you guys, it's sort of considered bad manners mathematically to have a radical in the denominator. So let's take care of that. Right? The square root of 47 over 3 is the same as square root 47 over square root 3. If I want to get rid of the square root 3 in the denominator, I'm just going to multiply top and bottom by square root 3. So square root 3 times square root 3 is just 3. I think 47 times 3 is 141. I'm going to check on, I got a calculator off to the side here. Yeah. Square root 141. Good news is there's no perfect squares in square root 141. Okay, so now I'm going to rewrite this. It's going to be t plus 4 equals plus or minus square root 141 over 3. Remember, these two are the same numbers, they're just written differently. And now I can bring the 4 over to the other side. So it'll be t equals a minus 4 plus or minus the square root of 141 divided by 3. And we can leave the answer like that.